Good day, I'm Dr. T. Welcome to my office. I'd like to talk to you about a book, specifically the 1962 book Structures of Scientific Revolutions by Thomas Kuhn. Thomas Kuhn is one of the first scientific philosophers. He's not a philosopher that's using science, but he's actually a scientist slash philosopher looking at the philosophy of science. How does science really take place? What is science really? Not the textbook definitions, not what we say it is, but how does it really work? How does this knowledge making that we call science actually work, and what is the underpinning guidance for this? And as I mentioned earlier, this is, copyright 1962, at least the original version. There was some updates. So this is actually going to sound, in some respects, a little bit cliche. It's not that he was borrowing ideas from others. It's that many people borrowed his ideas and then kind of overused them to the point of cliche. So his fundamental ideas is kind of centered around one kind of core idea, and then it has a couple of major branches. And that core idea is the paradigm. And you're like, yes, I've heard of paradigms. He is the reason you've heard of the paradigm, and what you think of as a paradigm is basically what he came up with. Before that, the word didn't quite mean what it means now. So he comes up with this idea of a paradigm, and it's with respect to science, and he's looking at a very small discipline. So this is not all of science. A paradigm would apply to a specific group of researchers looking at a certain specific topic. And the paradigm is a mixture of how we understand the world, what he called the model, which is what we still call it. And this is looking at our understanding, looking at what's going on. And this is kind of the idea that we have in our head, that how the world works. And quite often this is turned into mathematical equations. So Newton's laws, F equals ma and the like, those would be part of the model. And obviously, we're not talking all-encompassing. We're talking for those scientists that are using that topic. So as a chemist, I'm not using F equal ma that much. I mean, occasionally, but not very often, because that doesn't really deal with what I'm dealing with. So my model would be slightly different. If you look at a model of the solar system, that's exactly what we're talking about. So we've got this model, but on top of that, we've also got different ideas. What is valuable? What is important? What questions are good questions to be asked that we don't know the answer to? So you take the model, you ask questions, you do some science, you refine the model, you tweak, you fix the bugs, that kind of stuff. And that process is called normal science. And most of the time, science is just doing this. Now, Kuhn obviously was writing in the 60s, well, I guess writing in the late 50s, actually publishing in the 60s. Things have changed. He's a member of the Great Generation. I'm a millennial, an old millennial, but a millennial. So I would argue that the paradigm has one more level. Not just the model, and then kind of this unspoken attitudes. What I would call the Zeitgeist, which is, the spirit of the age, the underlying ideas and values of a certain time. Kuhn did not call it Zeitgeist, but I think the word would fit nicely there. I would argue that the third part of that is technology, which Kuhn didn't really bring up. But if we start looking at the questions you ask and how you do science, obviously what technology you have dramatically changes what you can do. Imagine a pre-computer world. A lot of the way you're going to design experiments are going to be fundamentally different. The way you're going to do, say, space exploration when you don't actually have rockets that can leave Earth's orbit and are insanely expensive to start with. Yeah, you're not going to do the same thing as nowadays we could, do CubeSats and small rovers that are autonomous. And things have changed, and I think that has really changed the way we do science. So I think that really needs to be part of the paradigm. Okay, so you got the paradigm. It's your idea of how the science is working. How do you think the world really works? What do you value? And I would say the technology you have to do that. And while that doesn't change much over reasonably large courses of time, potentially the career or careers of many scientists, obviously technology has changed a lot. But that period is kind of normal science. You're asking the same types of questions, refining your model. Now, Kuhn then brings up that something happened. Slowly, incongruencies start coming up. Data that just doesn't get explained by the model. It doesn't fit in. It just doesn't work with the model. For a further explanation, I've got a video on phlogiston theory that would be useful to see. And the model just doesn't work right. Or the answers to the questions, maybe they work with the model, but the zeitgeist is changing. Those things that have become of value don't really line up all that well with the data you're getting and how that model is maturing. Or, and I would argue, Kuhn doesn't really do this, a new technology changes the fundamental way you think about doing experiments, changes the type of experiments that you're able to do. Hey, all of a sudden we have the James Webb Space Telescope. We can start looking for extraterrestrial or extrasolar planets. Yeah. So at this point, science goes into this kind of crisis mode, specifically if the model always starts breaking down. It looks like your fundamental understanding of the world is deeply flawed, which is what happened in the phlogiston case. At that point, then there is what's called a paradigm shift, where you are taking, over the course of usually a fairly short period, or Kuhn would argue a very short period, a matter of months, the scientific community for that narrow area, so he's not talking every scientist ever, we're talking just that kind of narrow scope of scientists, fundamentally restructure the way they think about the world and then move to a new paradigm. Their model has been drastically updated. Their values have changed. Something that they thought was worthless is now a very interesting, very important piece of research. Or I would argue they now have a new and very valuable tool to use in their exploration. But fundamentally, there's a major break with the way science was done and the way science is continuing on. And that's your scientific revolution, your paradigm shift. But then proceeding is a very slow, iterative process of building data, refining the model, improving our understanding, but it's a very slow, steady plod. So that science really moves in this kind of slow creep and then jumps. So it's this kind of jerky motion where, slowly build, slowly build, slowly build, and then in a very short period of time, profoundly changes, and then slowly builds, slowly builds, slowly builds. And we look back on that, and we look at it as this intuitive, linear process, but Kuhn then kind of extends that as like, no, during those times of crisis, we were exploring every possible idea. We were trying to figure out what was going on. And it was not this clean, linear progression, stepwise. It was, once again, slow steps, and then these big jumps that you could not see where you would land from when you jumped off. These were very dramatic things. But these are, once again, major jumps that don't happen on a very regular basis. Presumably, your model is reasonably correct, and thus it's not going to drastically change. And you may get a new wonderful tool, but truth be told, technology usually doesn't just boom out of nowhere. It does occasionally. It slowly grows. So your paradigms will shift a little bit slower. You still have the same values. You're still trying to get the same goals. So yeah, that's Kuhn's core idea, this idea of normal science punctuated by these chaotic times of paradigm shift into these new paradigms and new normal for normal science. Now, as far as the book goes, as a recommendation to read it, I can't give it a particularly strong recommendation. It's definitely dated. As I mentioned, he doesn't really talk about the role of technology, which I both sort of understand and sort of don't. He's, member of the Great Generation. I'm a millennial, of course. We've been talking technology since I was born. The rate of change has increased, but he saw a huge and profound shift in the way science was done just within his life, up until the point where he had wrote the book, let alone later on. It doesn't really take into account that. Obviously, it doesn't have kind of a modern, more global view of the origins of science, so it's definitely very, very, very Eurocentric. So that there's definitely certain areas that as a modern reader you go like, really? Well, that was the way it was. We've grown since then. So for those who are studying philosophy of science, history of science, this is a quintessential book. This really is what sets off what we would now call a philosophy of science. This is the definitive initial work. For those who aren't really studying that, your run-of-the-mill scientist, layperson, there are other later works that have, once again, a more modern, more nuanced view that borrow heavily from his work. So, things like Crash Course History of Science. I would have to recommend those over his work just because it definitely really does feel dated. But it's still an important work. It's an important, milestone in our understanding of how science works. So if you do want to deep dive into that, it's definitely an important read as a kind of a primary source, an understanding of the view at the time, which is definitely still, in many respects, very influential to how we understand the way science works. So with that said, have a wonderful day.